It is a great pleasure to introduce our project, Bridging Data and Intelligence toward Reliable RA Diagnosis. Let me begin by outlining our ultimate goal. Our aim is to establish the world's first and largest multi-center, multi-regional, and multi-ethnic hand X-ray dataset for rheumatoid arthritis, and to develop a reliable AI-assisted diagnosis model based on it. Now, to better understand this project, let us take a closer look at the detailed overview. Rheumatoid arthritis is a common autoimmune disease that primarily affects the synovial joints, causing progressive joint destruction and functional disability. Radiographic evaluation remains the gold standard for both diagnosis and long-term management, where joint space narrowing, bone erosion, and others are the main indicators of disease progression. In recent years, computer-aided diagnosis and AI-based systems have gained increasing attention for their potential to provide objective and efficient evaluations. However, despite rapid progress in AI, their application in RA diagnosis has been severely limited by the lack of large and well-annotated datasets. Existing RA datasets are often small, incompletely annotated, and closed to the public. As a result, both technical innovation and clinical research have been significantly hindered. Therefore, a large and diverse RA dataset called RAM-10000 is being built. Meanwhile, a reliable AI diagnosis model will be developed to deliver objective, reproducible, and explainable assessments of RA. This is where the dataset RAM-10000 comes into play. The RAM-10000 project aims to construct a large and diverse hand X-ray dataset for RA research and AI development. It will include more than 10,000 images collected from over 20 medical centers, spanning over 10 regions and 3 major ethnic groups. Such diversity ensures that variations in imaging protocols, population characteristics, and healthcare environments are well represented. To make this dataset truly useful, multitask annotations will be provided. It will include bone segmentation, lesion segmentation, and SVDH scoring of both joint space narrowing and bone erosion. In this way, RAM-10000 will not only serve as a data resource, but also as a comprehensive benchmark for developing and evaluating CAD and AI models in RA. Once this dataset is established, the next step is to build the diagnostic intelligence upon it. Based on RAM-10000, a reliable and comprehensive AI diagnostic model will be developed. This model will segment bones and lesions, assess JSN and BE scores, and integrate findings through reasoning to produce a structured and explainable diagnostic report with visual evidence. By combining data-driven insights with clinical interpretability, this model is expected to bridge the gap between AI algorithms and real-world clinical decision-making. Now, let us turn to what this project means for the broader scientific and clinical communities. First, by providing high-quality ground truth and benchmark datasets, our project will promote fair and reproducible evaluation of RA diagnostic algorithms. Second, the large and diverse imaging data will lay a strong foundation for building large-scale, generalizable AI models, enhancing their robustness across different populations and imaging conditions. Finally, the dataset will enable new opportunities in clinical and epidemiological studies, supporting large-scale investigations on disease progression, treatment response, and population-level trends. Through these contributions, we hope to make a scientific impact significant enough to stand on the global stage, aiming for publications in leading journals such as Science or Nature. Ultimately, our mission is not limited to building a dataset or a model. It is about establishing a new research foundation that connects clinical expertise, large-scale data, and trustworthy AI. To support this vision, we have already conducted a series of preliminary studies to verify feasibility. A preliminary project named RAM-10000 has been developed. This dataset focuses on the wrist and serves as a multitask benchmark for RA. It includes instance-wise bone segmentation for all wrist bones and SVDH bone erosion scoring for 6 joint surfaces. This work was accepted by the NeurIPS Core 25 datasets and benchmark track, marking a significant milestone toward the larger-scale RAM-10000. It is worth noting that NeurIPS ranks among the world's top 10 scientific venues alongside Nature, Science, and the New England Journal of Medicine. Such recognition demonstrates both the technical rigor and clinical value of our work. In RAM-10000, comprehensive annotations were provided, the dataset was released openly, and multitask benchmark protocols were established, all of which have laid a solid foundation for the next phase of our research. The project looks forward to your collaboration. We sincerely invite contributions from the global RA and medical imaging communities. Your expertise, imaging data, and feedback on annotations will play a vital role in ensuring that this project remains clinically grounded and scientifically rigorous. Together, we shape the future of smart RA healthcare. Thank you.